Exercise says form the pair of linear equations in the following problems and find their solutions if they exist by the elimination method. So we have these 5 word problems, and for each of these we have to set up a pair of linear equations and solve that pair to find the unknowns. So let's start with the first part. So the first part says if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes half if we only add 1 to the denominator. So what is the fraction? So the unknowns in this case are the numerator and the denominator of the fraction. So let's assume that the numerator is x and let's assume that the denominator is y. So this means that the original fraction will be equal to x by y. Now let's set up a pair of linear equations using the information that's given to us. So the first piece of information says if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. So if we add 1 to the numerator and if we subtract 1 from the denominator, the fraction becomes 1. The fraction reduces to 1. So this gives us our first equation in x and y. So let me cross multiply y minus 1 and write this in the standard form. So x plus 1 is equal to y minus 1, and I can write this as x minus y plus 2 is equal to 0. So this is the first linear equation in x and y. Now let's use the second piece of information. The fraction becomes half if we only add 1 to the denominator. So if we don't change the numerator and if we add 1 to the denominator, so the new fraction becomes x by y plus 1. This becomes half, and this gives us the second equation in x and y. So let's cross multiply. So we have 2 times x and y plus 1 times 1. So 2x is equal to y plus 1, and I can write this as 2x minus y minus 1 is equal to 0. So we get two linear equations in x and y. The first one is, so let's write them here. So the first one is x minus y plus 2 equal to 0, and 2x minus y minus 1 equal to 0. Now we have to solve this using elimination. So let's do that now. So we can see that the coefficients of y in both the equations are the same. So in the first equation, the coefficient y is minus 1. In the second equation, it's also minus 1. So all we need to do is we need to subtract these two equations, and that will eliminate y. So let's call these equations 1 and 2. And now let's do 2 minus 1. So what will happen? The y terms will get cancelled out and we'll have 2x minus x. So that's 2x minus x, and we will have minus 1 minus 2. So minus 1 minus 2, and on the RHS we will have 0, and this gives us x equal to 3. And from x equal to 3 we can find the value of y by substituting this value into the first equation. So y is equal to x plus 2, or y is equal to 5. So x is equal to 3 and y is equal to 5, which means that the original fraction should be equal to 3 by 5. Now let's verify if this answer aligns with what's given to us. So if we add 1 to the numerator, so the original fraction is 3 by 5, and if we add 1 to the numerator it becomes 4, and if we subtract 1 from the denominator it becomes 4. So 4 by 4 is equal to 1. So this aligns with the first piece of information given to us, that the fraction reduces to 1. And now if we add 1 only to the denominator, so the numerator is untouched and the denominator becomes 5 plus 1 or 6, and 3 by 6 is equal to half, and this is equal to the second, this aligns with the second piece of information given to us. So our answer is correct. The original fraction is 3 by 5. The second part of this question says 5 years ago Noori was thrice as old as Sonu, and 10 years later, Noori will be twice as old as Sonu. How old are Noori and Sonu today? So the two unknowns in this situation are Noori's present age and Sonu's present age. So let's assume variables for them. So let's say that Noori's age today is n years, n for Noori, and let's assume that Sonu's age today is s years, s for Sonu. Okay, now we are given two pieces of information, and using those we have to set up a pair of linear equations in n and s. Now the first piece of information says 5 years ago Noori was thrice as old as Sonu. So 5 years ago Noori's age would have been n minus 5 and Sonu's age would have been s minus 5, and Noori was thrice as old as Sonu. So n minus 5 should be 3 times s minus 5. So this gives us our first equation in n and s. Let's expand and write this in the standard form. So we have n minus 5 is equal to 3s minus 15, or n minus 3s plus 10 is equal to 0. So this is the first equation in n and s. Now the second piece of information given to us is 10 years later Noori will be twice as old as Sonu. So 10 years later Noori's age will be n plus 10 and Sonu's age will be s plus 10, and the statement says that Noori will be twice as old. So n plus 10 should be 2 times s plus 10, and this gives us the second equation in n and s. Let's simplify it. So we have n plus 10 is equal to 2s plus 20, which means that n minus 2s minus 10 is equal to 0. So the two equations we get are n minus 3s plus 10 equal to 0. So let's call it 1. And the second equation, n minus 2s minus 10 equal to 0, let's call it 2. And we see that the coefficients of n in both the equations are the same. We have n here and we have n here. So all we need to do is subtract the two equations, and that will eliminate n. So let's do 2 minus 1. So by doing 2 minus 1, what will happen? On the LHS, n and n will cancel and we'll be left with minus 2s and minus 3s. So minus 2s minus 3s, and from here we'll have minus 10, and then from this equation we'll have minus 10 once more, and on the RHS we will have 0. So this gives us minus 2s plus 3s. So minus 2s plus 3s minus 20 is equal to 0, or s is equal to 20. So we get s equal to 20, and now let's substitute this value of s into any of the two equations. Let's put it into the first equation to get the value of n. So n will be equal to 3s minus 10, or 3s is 60 minus 10 or 50. So n will be 50, n is 50 and s is 20. So Noori's present age is 50 years and Sonu's present age is 20 years. Now let's verify if this solution is correct. So 5 years ago Noori's age would have been 45 years, 50 minus 5, and Sonu's age would have been 15 years, and 45 is thrice of 15. So this aligns with the first piece of information given to us. And then 10 years later Noori's age would be 60 years, 50 plus 10, and Sonu's age would be 30 years, 20 plus 10. So Noori's age will be twice that of Sonu's age. So this aligns with the second piece of information given to us. So our answer is correct. Noori's present age is 50 years and Sonu's present age is 20 years. Part 3 of this question says the sum of the digits of a 2-digit number is 9. Also, 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. So at first glance, this statement, the problem statement, may sound quite confusing, But the secret to solving such problems is to carefully read through the statement, deconstruct it, and make the linear equations step by step. And you will find that even in this case where it's seemingly confusing, the actual equations are really easy to set up. So we have to find the number, and the two unknowns in this case are the 2 digits of this number. So the number is a 2-digit number and both its digits are unknown. So let's assume that the ones digit is x and the tens digit is y. So the number, when we write this number in the normal form, it will look like this, yx. So this is the number. So note that this is not a product of y and x. This is just when we represent the number in the standard form, this is how we will write it. We will write the tens digit first and then the ones digit. Now let's look at how we can put together a pair of linear equations in x and y. The first piece of information says the sum of the digits of this number is 9. So this one is actually quite straightforward. X plus y is equal to 9. So this is our first equation. Now the second piece of information says 9 times this number. Now let's stop here for a moment and think about what this number actually is, what its numerical value is. So the ones digit of this number is x and its tens digit is y. So its actual numerical value will be 10y, because y is the tens digits. So 10y plus x. So this is the numerical value of this number. Now this second piece of information says 9 times this number. So that's 9 times 10y plus x is equal to twice the number obtained by reversing the order of the digits. Now the reverse number will look like xy when written in standard form, and the numerical value of the reverse number will be 10x plus y, because in the reversed number the digit at the tens place is x and not y. So we have 10x and then we have the ones digit, which is y. So coming back to this piece of information, it says 9 times this number, so that's this expression here, is twice the number obtained by reversing the order of the digits. So the number obtained by reversing the order of the digits is 10x plus y, and this 9 times this original number is twice of this reversed number. So this is how you set up the equation in this case, and this gives us our second equation in x and y. Now let's expand and rewrite this in standard form. So we have 90y plus 9x is equal to 20x plus 2y. There is no constant term on both sides. And now let's collect the terms in x and y. So 9x, I take it to this side and subtract it from 20x, so I will get 11x, and then I can subtract 2y from 90y, so that gives me 88y. So 11x is equal to 88y, or x is equal to 8y. So this is the second equation in x and y, x equal to 8y. Now let's write them together and then let's use elimination to solve this pair of equations. So the first equation is x plus y is equal to 9, and the second equation is x equal to 8y. So let me write it as x minus 8y is equal to 0. So now all we need to do is, because the coefficients of x in both the equations are the same, we can simply subtract them. So we can do 1 minus 2. So what will this give? So the x terms will cancel out, and on the left side I will be left with y minus 8y, and on the right side I will have 9 minus 0, or 9. So this gives me 9y is equal to 9, or y is equal to 1, and y is equal to 1. This means that x is equal to 8y, or x is equal to 8. So in the original number, the ones digit is x or 8, the tens digit is y or 1. So the original number is 18 and the reversed number is 81. And now we can see that the sum of the digits in the original number is 9, which aligns with the first piece of information given to us. And also 9 times this original number, so 9 times 18, 9 times 18 is 162. This should be equal to twice the reverse number, so twice of 81, and twice of 81 is also equal to 162. So this also aligns with the second piece of information given to us. So our answer is correct and the original number is equal to 18. Part 4 of this question says, Meena went to a bank to withdraw 2000 rupees. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and rupees 100 she received. So she got notes in denominations of rupees 50 and rupees 100, but we don't know exactly how many notes of each denomination she received. So the two unknowns in this situation are the number of 50 rupees notes. So number of 50 rupees notes. So let's call this unknown X, and the number of 100 rupee notes. Let's call this unknown Y. Now, what are the two pieces of information that can help us set up a pair of linear equations in X and Y? So, well, we know that Meena got 25 notes in all. So the number of 50 rupees notes and the number of 100 rupees notes should add up to 25. So that gives us our first equation. X plus Y should be equal to 25. Now, we also know that Meena withdrew a total of rupees 2000. So the total value of these 50 and 100 rupees notes should be 2000. Now, because there are X 50 rupees notes, the total value of these notes is 50x, and there are Y 100 rupee notes. So the total value of these notes is 100y, and the total of these two values should be equal to 2000. So this is the second equation that we get in X and Y. If you want, you can actually simplify this second equation a little bit by dividing throughout by 50, because 50, 100 and 2000 are all multiples of 50. So if I divide this second equation by 50 on both sides, I will be left with X plus 100 by 50 is 2, so 2y, and equal to 2000 by 50, so 2000 by 50 will be equal to 40. So the two equations we have are X plus Y is equal to 25, so let's call it equation 1, and X plus 2y is equal to 40, so let's call this equation 2. And now the coefficients of X in both these equations are the same, so all we have to do is subtract these two equations to eliminate X. So let's do 2 minus 1, and by doing this, what will we have? So on the LHS, these X terms will cancel out, and we'll have 2y minus y on the LHS, and on the RHS we will have 40 minus 25. So this gives us y is equal to 15. And now we can substitute this value of y into any of the two equations 1 or 2 and get the value of X. So X will be equal to 25 minus y from the first equation, and because y is equal to 15, so X is equal to 25 minus 15 or 10. So X is equal to 10 and Y is equal to 15, which means that the number of 50 rupees notes is equal to 10 and the number of 100 rupees notes is equal to 15. And now we can verify whether this answer is correct. The total number of notes is 10 plus 15 or 25. This aligns with this fact that Meera got a total of 25 notes, and the total value of these notes will be, the total value of the 10 50 rupees notes will be 500, and the total value of the 1500 rupee notes will be 1500, So 500 plus 1500 is 2000, and that aligns with the fact that Meera got a total of 2000 rupees. So our answer is correct. The number of 50 rupees notes is 10 and the number of 100 rupees notes is 15. Part 5 of this question says, a lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Sarita paid 27 rupees for a book kept for 7 days, while Susie paid 21 rupees for a book she kept for 5 days. Find the fixed charge and the charge for each extra day. So the two unknowns are the fixed charge and the charge for each extra day. So let's assume variables for them. So let's say that the fixed charge is rupees X, or let's call it F for fixed, and the charge per extra day, so this is a charge per extra day beyond the first 3 days. So let's call it rupees C. So F and C are the two unknowns, and using the given information we have to set up a pair of linear equations in F and C. Okay, now what is the first piece of information given to us? So the first piece of information is Sarita paid 27 rupees for a book she kept for 7 days. Now for a book she kept for 7 days, she would have to pay rupees F as the fixed charge for the first 3 days, and then she kept it for an extra 4 days. So she kept it for 7 days, and this is 4 more than the first 3 days. So the number of extra days is 7 minus 3 or 4. So 4 extra days, and the charge per extra day is rupees C. So 4C is the total charge for extra days. So the overall cost Sarita would have to pay is F plus 4C, and this we know is equal to 27. So this is the first equation in F and C. Now the second piece of information given to us is that Susie paid 21 rupees for a book she kept for 5 days. So for 5 days, Susie would have paid a fixed charge of rupees F, and now she kept the book for 2 extra days. So the first 3 days, so beyond the first 3 days, she kept it for another 2 days for a total of 5 days. So Susie kept the book for 2 extra days. So she incurred an extra charge of 2 into rupees C or 2C. And the total charge that Susie paid was F plus 2C, and this was equal to 21. So this is the second equation that we get. Let's label the two equations as 1 and 2. Now we see that the coefficient of F in both the equations are the same. So all we need to do is subtract the second equation from the first. So we can do 1 minus 2. And what will that give us? So on the left side, the F and F terms will cancel out, and we'll have 4C minus 2C on the left side. And on the right side, we will have 27 minus 21. So this gives us 2C is equal to 6, or C is equal to 3. So the charge per extra day is 3. And now let's substitute this value of C into any of these two equations. So let's substitute this into equation 2 and find the value of F. So F will be equal to 21 minus 2C, and 2C is 6. So 21 minus 6 is 15. So we can conclude that the fixed charge is rupees 15 and the charge per extra day is rupees 3. Now let's verify whether our answer is correct. So Sarita took the book for 7 days. So she would need to pay 15 rupees as fixed charge, plus for the 4 extra days she would have paid 4 into 3 or 12. So 15 plus 12 is 27. So this aligns with the fact that Sarita paid rupees 27. Similarly, Susie kept the book for 5 days. So she would have paid 15 rupees as fixed charge, and for the 2 extra days she would have paid 2 into 3 or 6 rupees. So 15 plus 6 is equal to 21. So this aligns with the fact that Susie paid rupees 21 for the book. So our answers are correct. The fixed charge is rupees 15 and the charge per extra day is rupees 3. So that